Ngalakin Khadijan Nyunga Boja.
Good afternoon, everyone. Welcome to the second lecture of Electrical Engineering Design 1. Just a quick update on this. Lila is presently unwell. So for urgent matters regarding the unit, please email me directly. Someone will answer this for non-urgent matters, but it may take a few days. Just a reminder regarding COVID, we've discussed this in the previous lecture, just be wary and courteous. Right, this is the second lecture, as I said. Just want to give a quick update on where we are before we move on to the lecture material. So basically we're at the second week. We lost the Monday to a public holiday, so Gemma came in and recorded the lecture for us. This week you're covering your individual PPIR, etc. Your supervisors will give you more details regarding what needs to be done within each team meeting. I put up a notice regarding the notebooks. We now have a mechanism for you to submit them through the chat in MS Teams. And basically, that's what you're expected to use for the rest of the semester. More detailed overview, there is material that you should be looking at on LMS in the week 2 area. And that will help you with the formal meetings that start this week, the assessed formal meetings that start this week. Few extra items that have been added to the LMS since the last lecture. Basically, week 3 and week 4 material have, week 5 material have arrived. I think week 4 is empty at the moment. The material in these 2 weeks cover the requirements analysis, provide you templates and guides for putting together your requirements analysis, as well as the marking rubric. So I urge you to go and have a look at that. There was one student who seems to have started early putting their requirements analysis together. So because of that student, I've made this material available earlier than week 3. In addition, Adrian has put up some more material, some very nice material on making teams work. And I recommend you all go through, have a bit of a look at that material and make use of it in your teams and team discussions. Right, now I'd like to introduce Gemma Hamilton, who will be giving you the remainder of the lecture covering requirements. Gemma is a former student of UWA and has been working in the mining sector for many years. She's also been supporting this unit heavily, both by giving guest lectures and as an industry supervisor for some teams for quite a number of years. So we're very grateful to have Gemma come and guide our students with her expertise. And I am now going to pass on to her to continue the rest of the lecture.
Good morning, everyone, and welcome to the requirements lecture. My name is Gemma. I'm an electrical engineer with over 15 years experience, mostly in mining. Currently working on a project where it's a gold mine and they've finished the surface operations. So we're designing underground operations, which is quite exciting. I'll probably refer back to that project a bit throughout this lecture. So today we're going to talk about why do we need to define what the requirements are in a project, what the process is, who are the stakeholders, which ends up being quite important, what are some attributes, types of requirements, how do we assess them, and I'm going to give you some examples which will hopefully help you out with your assignment that's coming up. So the requirements analysis is important because we need to define and document, and also we have to maintain what the requirements are as part of our engineering process. And it is very important that they're documented and that we continue to maintain them throughout the project, because requirements do change as the project goes along. Design problems are open-ended, so we need to make sure that we have nailed down what the actual design needs to be, so that we don't go off on a tangent and we can complete the design for our client. The project brief that our client gives us very rarely contains all of the information that we need to complete the project. So we need to help them nail down what do they actually want as part of their design. But we also need to work out what is their highest priority and what are lower priority requirements. We need to prevent cost and time blowouts. Requirements really help with these. And we also need to track and assess changes. Again, if we track and assess the changes as we go along, then this will prevent the cost and time blowouts. So the process of defining the requirements is we need to identify who the stakeholders are in the requirements. We need to elucidate or gather all of the requirements from our stakeholders, analyse them all. So we need to work out what are their priorities, and we need to specify them. We need to make sure that they are very specific and that we can work out how to assess them. And finally, we need to manage the requirements. As I said, we need to manage any changes that happen throughout the project, the requirements. That might include changes to the requirements themselves, or it might just be a change of priority in the requirement. So the stakeholders, there are lots of different stakeholders on a project. It's any person who will influence what the requirements are, or someone who is impacted by the requirements. And you will often have conflict between stakeholders, especially about what they think the highest priority requirement could be. So some of the stakeholders might be people who get to make the decisions, so the people who have the funding for a project. One of the big ones are the people who will be operating or maintaining the final design, but also we need to think about people who might be negatively impacted by a project or the community. And we also need to think about the construction team. How are they going to actually build the project? There are some other examples I've given there of stakeholders. So we need to think about who are the most important stakeholders, because they will have more influence over what the requirements are and the requirement priorities. We need to have a think about what their motivations are, what their level of expertise is, because obviously some stakeholders will have a lot more expertise in the project than others. And we need to think about also what is their availability for communication. Some stakeholders are really hard to get hold of, but they might be the most important stakeholder. They might be the person who has the financial influence, for example. So we need to really think about nailing down what questions that we have, so that when we do get hold of those stakeholders, we can make the most of our time with them. So then when we finally have worked out who our stakeholders are and what influence they have on the requirements, then we get together all of our questions so that we can work out what the requirements are and their priorities. And here's some different ways that you might do that. So you might have some workshops. This is very common, that will get together a bunch of stakeholders and have a workshop. They might have prepared some reports or a project brief that you could go through, and then you might go back to them with some questions, for example, some RFIs, some requests for information, so that you can get further details on what the requirements may be. You might also define some requirements by performing some simulations and modelling. This is very common in electrical engineering, so that you can determine what your requirements might be with regards to electrical load, for example. So here's some examples of some types of requirements, and I'm going to go into more detail in these in a moment. Obviously, there's a lot of different types of requirements, and this will depend on what your client's priorities are. So cost, the most obvious ones are cost and time. Cost is almost always a requirement. I don't think I've ever had a project where cost isn't a requirement. And cost can be broken into different parts. So there's the capital cost, that's to purchase your equipment, but you also have installation costs and then ongoing maintenance costs, and this will include people working on it, maintenance, but also spares. And then last of all, we need to think about what are the end-of-life costs. So there will be different end-of-life costs depending on your project and depending on whether parts can be recycled or how they need to be removed from the site, and if you have to do rehabilitation, for example, on a mining project. The physical characteristics are always a requirement, so we need to have a think about how much something weighs, how you're going to get it to its final location, and clients will almost always specify what type of paint or what type of protective surfaces that they want on their equipment, or maybe they want plastic, or maybe they want something galvanized. So that's something that is often not really thought about with electrical engineering, but is very important. Capacity is obvious. How many of whatever it is do we need? How big do they need to be? We need to have a think about the performance requirements. So for example, with transformers, something I specify very often, we need to think about the flammability. So for transformers that are oil fueled, there are different types of oil that we can get to fuel the transformer. And it might not seem that obvious, but if you get a more flammable oil in a big transformer, then you need to build blast walls around the transformer. It will actually take up a lot more space and a lot more money for the civils to build this huge concrete wall. So have a think about those sorts of things. IP rating is also another one that is very important. IP for intrinsic protection, because we need to think about what sort of environment is the equipment being installed in. So is it being installed outside where it will get wet, or is it being installed in an office where it's cool and not dusty? We need to have a think about how is the design going to be built? Is it going to be very difficult to be built? Is it going to be built in a small place? Is it going to be built somewhere big and open where this isn't going to matter? We need to think about what sort of people are going to be building it. Are they going to be very skilled workers, or are they going to be unskilled workers? We need to have a think about if it's going to be built overseas and brought to Australia or to a site elsewhere, how is it actually going to be brought here? Some things can't come on a plane, they have to go by ship. So you need to include the lead times of the shipping in your time schedule. So have a think about all of this stuff. If it's a very short project, then you want to be able to specify equipment that can be brought here by plane, for example. These are some of the most important ones that are often forgotten. Who is the end user? How are they going to actually use your design? And what do they actually want to get out of your design? Don't over-design the project. Don't put in things that they're never going to use. Don't make it too complicated, because the operators at the end of the day are very likely not going to be engineers. So we need to make it something that will be easy for them to use and that they will be able to work out, that will be intuitive. Regulatory requirements. So going back to my example of the gold mine that I'm working on, it's in New South Wales. So I have a lot of New South Wales mining requirements. There are also a lot of Australian standards. So Australian Standard 3000, the wiring rules, that's a regulatory requirement for all Australian projects. And then think about, you may need to pay some license fees, for example, if you're purchasing radio bandwidth for a mine site. So think about those sorts of things. What regulatory requirements do you have? If you don't comply with these, the project won't be able to go ahead. Think about the final lifetime of the project and how you're going to dispose of all of the parts when the project is finished. Every single project I've had has had a requirement for lifetime. So, for example, the project at the moment is 20-year lifetime. Obviously, not all parts will last for 20 years, so we get spares so that we do end up having a lifetime of 20 years for the project. So have a think about all of that. The environment, what is the environment that your equipment will be installed in for your design? So we will always specify things like not just temperature and humidity, but also whether there's earthquakes. Have a think about that, and also noise requirements. So transformers can be very noisy, so we'll always specify what the maximum noise can be. And again, this will depend on whether it's a design that's going to be installed in the middle of nowhere, or is it going to be something that's going to be installed in someone's office or in their front yard? Obviously, all of these things will impact what your limitations will be. Once we have established all of our requirements, we need to analyse them. We need to look at whether there are conflicts or inconsistencies. There will always be some conflicts in the requirements, which means we then need to prioritise them. We need to work out what is the highest priority requirement. We need to have a look to make sure we haven't missed anything important, and we need to identify our constraints. For example, time is always one of the biggest constraints. Good requirements are always independent of the design, so we can establish what the requirements are before we have done any design at all. They need to cover the whole life cycle of the project, and they need to be able to be verifiable by independent analysis or by tests. So we need to show that we have met the requirements at the end of our design. We need to be able to trace them. So give all of your requirements a code or a number so that you can refer back to which requirement you're talking about. And you need to make sure that they're not ambiguous. You need to be very specific with the requirement, because a contractor will find holes wherever they can, and where you can find holes in requirements or a specification, that's where you can make money. So we specify all the requirements by recording them. In your case, you're going to record them in your requirements analysis. And remember, as per the previous slide, we need to trace them. So give them a number or give them a code, because you will need to refer back to them later on. Here's an example of a specification that I've written recently, and I just wanted to show you that in my specification I have identifiable clause numbers. So in other documents I will refer back to clause 7.2, for example. I also refer to the Australian standard. In this case, that's a statutory standard. So you can see where I've said that there. And this is for a transformer, by the way. So I've been very specific also about what vector group I want. So that's D-Way and 11, because all of the other transformers that are already on site are that vector group. And if I don't specify that, then the manufacturer could give me any old type of transformer, and then it won't be compatible with the rest of the ones on site. So I just wanted to point out those three things because they're very important. When we finally finish determining all of our requirements, what their priorities are, we need to validate them. We need to have a think about what are any potential risks or hazards that could come towards the requirements. And for example, long lead times of equipment needing to come by ship, that is a threat or a risk. We also need to go back to our project partner or our client with what all of our requirements are. So in my case, I give them my specifications and my data sheets. You will give your project partner a copy of your requirements document, and they will give you feedback on whether the requirements are valid or if they want any changes to them. And they will let you know if they have higher or lower priority ones than how you have assigned them. So this is an example of a data sheet. This is for that same piece of equipment that I wrote the specification for, the transformer. So I just wanted to show you here that I've got, they're all numbered. So again, we can refer back to the number of each requirement. You can see some examples that I'd already mentioned on here. So we've got the location. So it's an outdoor installation. It's humid. It can get quite hot, 45 degrees. And then there are some things that we don't really mind. So we've left that up to the vendor or the manufacturer to let us know. So we don't really care where it's installed in this case because we have a lot of time to ship it. And we also have some very specific requirements to make sure it's compatible with our site. So 50 Hertz is important, obviously, in Australia, and 3 phases, the vector group, and here this Kainan. So that's the type of oil that we use that is much less flammable than the mineral oils that are previously used in Australia. So I don't have to have a blast wall. So that might seem like just a little thing having Kainan there, but that will significantly affect our civil design. You can have a look at what some of the other things that I've written here are, but I just wanted to show you also that we leave a column blank so that the manufacturer can come back to us and tell us that they have met these requirements or not met the requirements. So we can confirm them very easily. We can tick, 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 tick them off and say, yep, we have met the requirements in this case, or some of the requirements we haven't met. Let's go back to our project partner and see if they're happy with that requirement not to be met. Sometimes there might be if it's a priority. Throughout the project, we have to manage the requirements. They will change. Things always change on projects. Please be prepared for things to change on your project. They will. So we have to make sure that we keep on top of that. So keep on top of that with change management with your documents. Keep on top of that with good communication with your client, with requests for information. Document all of the responses that you get for all communication. Just make sure that you keep on top of that. Communication is the really big thing here. Make sure that you document everything so that when the client comes back to you and says, why did that change? You can say, we discussed this per RFI 22, for example. So almost always, something will be forgotten with a requirement. Again, that's okay. We'll go back and document and fix it. So don't forget about what some of your interfaces are. So the biggest ones, obviously, in a mining project are between electrical and other disciplines. So mechanical engineers might change the size of a conveyor drive and forget to tell us, and they actually need more power to that piece of equipment. Or maybe we will change the transformer mineral oil, and then we will need a blast wall. We'll have to make sure that we communicate with the civil engineers regarding that. So think about what your interfaces are within your team. Often with these design projects, it's really easy for you to go off and work in silos. You break up the work and you start working on your own design and you forget to interface with each other. So keep on top of that by having regular meetings and make sure that you don't just deal with your most important stakeholders, but have a think about your other stakeholders and make sure that you've covered off what's important to them, because they could be someone who puts a stop to your project ultimately. Also be really careful with differences in language. It might seem obvious, but if you have stakeholders who are from other countries, for example, they might be talking about imperial measurements instead of metric. So just have a think about who you're talking to, where they're coming from. Make sure you cover everything. So I've given an example here of a requirements table. So this is the sort of thing that we're looking for your requirements document. So I've numbered them here. You might want to think of a more elegant numbering system. Often we might have a letter for a category, but that's okay. That's entirely up to you. Be specific with your description. Be very specific. So the transformer, we don't just want a big transformer. We want one that's 2 MVA or larger. We have to comply with Australian Standard 3000. That's statutory requirement. So I said that that's unspoken. Isn't expected. And then your project partner might have something that doesn't really matter to the end of the design. It doesn't affect how things work. In my case, I don't really care what color paint the transformer has, but the client will be very specific because they will have their own branding and they will have their own way that they have their equipment painted on site and they want it all to match. So this is a client requirement that they have spoken. They want it to be agate grey. And I put that as a low priority because at the end of the day, it doesn't really matter that much. After you've completed your design and also throughout your design at different stages, we will test the requirements to make sure that they have been met. So there are different types of tests that will be performed. Type tests or functional testing are tests that are performed on the design itself. We also have factory acceptance tests, so often the engineers will go to the factory to attend these. And there will be checklists on what sorts of tests need to be completed to make sure that the requirements are complied with. And last of all, when the equipment comes to site, we will have site acceptance tests, which are also known as commissioning, and we will make sure that the design and the piece of equipment is actually fit for purpose, and we'll start it up. So here's an example of some tests. In this case, I've used a specification for cables because they're very specific once again. Ideally, you will tie them back to the requirements. So you will have them tied back to the requirements here. Which requirement are you meeting with each test? So you will need to do this later on. You need to show each requirement number and be very specific about what tests and how they need to pass tests. So this testing stage is type test. So this is before the cables are even built in the factory. A sample cable is built and subjected to all of these tests. Some of them are failure tests. And they need to measure different resistances for the conductor screen at very specific temperatures. So these tests are very specific. They're all per the Australian standards. And they are very specific on not just the description, but also how do they pass the test. For your assessment for your requirements document, you have 10,000 words. This includes everything. It includes your references, it includes your appendices, your tables, everything. You need to submit it in Word, not in a PDF, so that we can make sure that you have met the word limit. Again, I keep repeating this because it's important. Number all of your requirements. You will need to refer back to them in your later assessments. Make sure you've numbered them all. Make sure you've given them all a code. Prioritize them to more than 5 levels. 3 levels is not enough. You need to give at least 5 levels of priority because you will have a lot of them that end up being top priority. And ultimately, some of them will conflict. So you need to work out when they do conflict, how do you decide which one is more important? Make sure you cover all of your constraints. So have a think about your cost constraints, your time constraints, how much physical space you actually have, what sort of materials you could actually get here on time. And you need to state what is the source of each of your requirements. Where did you get the requirement from? Was it in the project brief? Was it in one of the design meetings? Was it from an Australian standard? Is it a statutory requirement? State where all of them are from. And lastly, you need to have IEEE referencing, as I have done here for my lecture. Thank you very much. I hope you enjoyed this. Good luck for semester, and I hope you have a good project.